Alright, after 5 minutes break, let's continue on the substitution rule to solve the definite integrals. And we know the difference between indefinite integral and definite integral, right? Indefinite integral actually is the function. Definite integral represents the net area, so should be a number, right? Should be a number. Now let's see how can we apply the substitution rule to work out the net area. So if the G prime is the same, okay, U equals Gx. G prime is continuous on AB and F is continuous on the range, okay, on the range of Gx, because it's still the composition FGx. Gx is the the range of this function gives the domain for function f. So then to evaluate the definite integral from a to b, fgx times g prime dx. So here with the lower and upper limit a and b, then that becomes fu du evaluated from ga to gb. Okay, so be careful. Here, the two definite integral, it change, the lower and upper limit change. When we use the x, of course, when we use the independent variable x, that is a to b. And then when we substitute for the variable u, that the lower and upper limit becomes the function of x. So ga and gb. And again, we should still specify what is the fgx, what is the g prime. Sometimes you might have the fraction in front of the integral sign like that, okay? And here the a, so it's the lower limit for the definite integral, okay? For the definite integral, lower limit x1 equals a, then that changes to, so lower limit, when we have the variable x, that is a, then when we have the variable u, then the lower limit becomes g evaluated at a, right? The function g evaluated at a. Then upper limit x2 equals b, then the upper limit for the u, that becomes the function g evaluated at b. So for the variable u, the lower and upper limit becomes ga and gb, okay? So if g prime is continuous, okay, it's the same statement. Now let's simply check how can we simply prove that, okay? How can we simply prove that? So here we understand that according to FTC part 2, okay, fundamental theory of calculus part 2, then for this integrand, okay, for this integrand, big F gx, okay, big F gx is any antiderivative, derivative of this integrand f gx times g prime. And we already verified that if you take the derivative of this composition function, and we know where the big F, right? The big F is the antiderivative of small f. That is the relation between big F and small f. If you take the derivative of this composition of functions with respect to x, this is like fu, right? fu. So that will be the derivative of big F, which is small f, evaluated at u, and then chain rule du over dx, right? So that's why we call, from here we can call fgx is any antiderivative of this one. So to evaluate this definite integral, we know this integrand, we find out the antiderivative, right? We find out the antiderivative for this integrand. So that will be the antiderivative evaluated at AB, then take the difference, right? This works the same as the one. Let me just use a different color to mention you about the FTC part 2, okay? FTC part 2. A simpler version of FTC part 2 will be evaluated fx from a to b dx. That will be its antiderivative big F evaluated at the two endpoints and take the difference. That is the general one. Now we have the composition of the functions as the integrand, right? We have the composition. We have this one as the integrand, and it doesn't matter if we work out, if we know its antiderivative, then it should be fine, right? So fgx is its antiderivative. That will be this one. So this one means when x equals a, right? When x equals b. So that will be f when x equals b, fgb, minus when x equals a. Just the composition of two functions comparing with the version in the FTC part 2. Here we have the composition of functions, but still apply the FTC part 2 like this one we did, right? Now here this is the left side, okay? This is the left side. The left integral equals fgb minus fga, so that is the left side. Then let's check the right side. The right side is more straightforward because it focuses on u. There is no composition of functions. And we know GA and GB, they are also numbers, right? They are not also numbers as the lower and upper limit. FU, DU, and still it's again the antiderivative. Okay, the derivative of big F gives small f. So the antiderivative will be FU, right? Will be FU. It's the same, right? It's the same. So the antiderivative for small f will be big F evaluated at u. And where is my u? My u should be evaluated at GA and GB. So second part is the lower and upper limit is based on the independent variable u. Then my u is GB, so I take the difference when u is GB. GB is just a value, right? How can we get GB? That is when x equals b, the function evaluated when x equals b, then minus fu. What is my u? My u is GA, the left endpoint. That is the right. Now we prove that left side equals right side. They are the same, right? They are the same. So here it's the same. Comparing with the indefinite integral, we have the integrand fgx, composition of two functions, fgx times g prime. And then you can rewrite this integrand as fgx g prime dx. We can rewrite it as fu du, but the lower and upper limit change, okay? The lower and upper limit changes to ga and gb. So in this way, we can evaluate the definite integral if we can work out the fu, right? Big fu. That is pretty easy. So now let's check this one. Okay, let's check this one. Under the root, it's not x. It's a function of x. And although it's pretty simple, it's just a linear function of x. So we can also use the substitution rule. Let the function inside the root, under the root as u, right? So here is A and B, right? The lower and the upper limit, A and B. Let's work out step by step, okay? Again, we should figure out my U is the gx, okay? My U is gx. And here you might ask, this is like the root U, this is only the composition function, fgx part. Now we need to figure out what is g prime, right? We need to have the part g prime, fgx times g prime times dx, then we can change into fu du, right? So gx is 2x plus 1. Then what is my g prime? My g prime is 2, right? My g prime is 2. Then this one again, you can take here as 1 times root 2x plus 1. You can take this one is something about g prime. Then how can you write this one? So 1/2 g prime will equals 1, right? Because g prime is 2. G prime is a number, right? It's not a function again, it's just a constant g prime because function g is a linear function of x. So g prime is a constant. So 1/2 g prime gives 1. So you can take this part is something about g prime, like that, okay? So here, what is my a, lower and upper limit? So lower limit, a is 0, right? I need to evaluate the lower limit for u, okay? What is my GA? And then B, the upper limit is 4. What is my upper limit for u? Let me ask someone to answer the question. What is the lower and upper limit for u? Alami, are you available? (60071), the student ID. Are you available? So what is GA and GB? So here is one. Yes, A is 1, but what is GA and GB? Then we can rewrite it from 0 to 4. No one reply? Any volunteer to answer this question? No? Alright, let me just continue. So when A is 0, okay, when A is 0, so X is 0, right? GA, okay, GA. So the GA is when X is 0, we get 1. And then when B is 4, GB in this function, when B is 4, right? When B is 4, then we get 9, right? 9. And then here, what is my FGX? What is the combination of the two functions? That is under the root 2x plus 1, right? 2x plus 1, which is root GX, right? It's the same as root GX. Now what is my FU? What is FU? So the function f, the function small f is the root, right? Root. So will be root u, right? Root u. So let me evaluate this definite integral here. And you can take this one as 1 times 2x plus 1, because this 1 indicates some relation between g prime, right? Between 1 and g prime. So this one we can write it as 1/2 g prime, right? 1/2 g prime. So here, what is my g prime? My g prime is 2. So I can move the 1/2 outside. I can write this 1 equals, here the 1 equals 1/2 g prime, right? I can move the 1/2 outside. What is my g prime? My g prime is 2. So this is g prime times fgx dx. So according to the substitution rule, here will be fu. This is fgx times g prime. That will be fu du the lower and upper limit change as GA, which is 1, GB, which is 9. And then find the antiderivative. Find the antiderivative for root u. Root u, we already get that 2 over 3 u to the exponent 3 over 2, and evaluate it at 1 and 9, like that. Then you get the answer for the definite integral first, then times 1/2, okay, times 1/2. So that is 1/2 inside, or actually you can move the 2 over 3 outside, okay, you can move the constant outside, it doesn't matter, okay, it doesn't matter. So here 1/2 times 2/3, which is 1/3, 1/3 inside is u, when u is 9, 3 over 2, which means take the square root, u cube minus, when u is 1, right, 3 over 2, which means take u cube, take the root, it's the same. So that will be, this will be 3 cube, 27, 27 minus 1, 26 over 3, right? So that is example 3, okay? That is example 3. Now let's check the solution. I typed here. Using the substitution rule, we have the u is the gx, right? Gx. Then we can rewrite, or you can rewrite this dx. You can take this dx as 1/2 du. It's the same way, okay? It's the same way. So we calculate the GA and GB, right? This part is the GA. The reason we calculate the u, this is the GA. We usually call the u1, okay? And when x is lower limit, when x is upper limit, this u2 gives GB, which is the upper limit for u, right? So here, the root 2x plus 1 is root u. Root u, how can we replace this dx? You can call it 1/2 du in that way, according to here, right? According to here. Then finally you get the answers, right? 1/2 times 2/3, you get 1/3 with those. So 26 over 3. There is no problem with this example 3. Then example 4, okay? Example 4. So example 4, here is dx over 3 minus 5x squared, okay? Dx over 3 minus 5x squared. So here the function will be a fraction, right? Fraction 1 over 3 minus 5x squared, and of course the u, okay, the appropriate u can be the function inside the parentheses 3 minus 5x, right? So it will be 1 over u squared. 1 over u squared, which is the same as u to the exponent minus 2, then which is easier to find the antiderivative, right? Now let's figure out each term, okay? Let's figure out each term. Find the appropriate u, gx, which is 3 minus 5x, right? 3 minus 5x, and then du over dx, which is my g prime, here. It's also, sorry, it's g prime x, so which is still, it's a linear function, so the g prime gives a constant again, right? So g prime gives a constant, which is minus 5. That's why here, first look, we only have the fgx, the composition part. There is no g prime in a direct way because g prime is a constant. So fgx will be 1 over 3 minus 5x squared. So my gx, it will be 1 over gx square, right? The reason I rewrite this fraction as a compositional function, there is no square in u. If you put u, then it's not easy. It's not easy to, if you put square for u, then it's not easy to find your G prime. And by the way, if you do 1 over u to find the antiderivative, it's pretty easy. But if you have 1 over u square, it's the same. You can still work out the antiderivative. It's pretty easy, u2 minus 2. Then this part will be much easier than square to work out G prime. Make sense? And you will introduce extra term if you have extra term of x if you get u square. We can try that. Okay, that makes things more complicated. Yeah, it's a good question to ask. So the reason I rewrite the fraction here, that is to show what is the function small f. So here fu will be 1 over u square, right? It doesn't matter it's 1 over u or 1 over u square because it will be easy, right? It will be easy no matter which one. It will be easy to work out the antiderivative. Then we forgot the lower and upper limit for u, right? So when a is 1 and 2, then let's calculate the lower limit for u, which is ga, which means when x equals 1. So that is minus 2, right? And then b is 2, so u2 is gb, which is when x is 2, which is minus 7, right? Which is minus 7. So here we are going to evaluate this definite integral. And it doesn't matter here, you don't have the G prime, okay? You don't have the G prime. So I'm going to rewrite this is my fgx, right? And then what is my G prime? I can take here is 1, so that will be minus 1 over 5 times G prime, right? Like that. Then dx, right? What is minus 1 over 5 times G prime? My G prime is minus 5, so this is 1, right? So you take this part, you rewrite this part, for 1. That's the reason why we did this part here is we should introduce the G prime inside fgx times G prime. So we can move the constant minus 1 over 5 outside, right? Minus 1 here when we are doing the x, it should be from 1 to 2, right? It's still 1 to 2 because the differential term is about x. So move the minus 1 over 5 outside, so that becomes 1 to 2, and we know what is G prime. We know what is the G prime. G prime is minus 5, right? We just rewrite the G prime here. Now it becomes the term fgx times the G prime. Fgx times the G prime, so keep the constant outside. That becomes fu du, 1 over u squared du. Now what is my GA and GB? Be careful. GA is minus 2, GB is minus 7. Now here you will notice that the lower limit is a greater number than the upper limit. How can we rewrite it? Recall formula. A to B fx dx. There is one rule, okay? Equals minus b to a fx dx. So if you will switch the lower and not upper limit, that introduce extra minus. So here, if you switch those minus 7 to minus 2, then you have the minus before, okay? You have extra minus. And then this minus with this minus cancel out. You have minus, you get the plus. So you only have 1 over 5. 1 over u squared du. What is the antiderivative for u2 minus 2? u2 minus 2. So that will be 1 over 5. u2 minus 2 should be minus 1, u2 minus 1 evaluated at minus 7 to minus 2, right? So the u2 minus 1 over minus 1, that is the antiderivative for u 1 over u squared. 1 over u squared, that is u2 minus 2, right? u2 minus 2. So that is also the formula, right? Also the formula. Then let's work out here. Let's continue the calculation here. So that is, which means you can put the minus outside, right? This minus 1 times 5, which is minus 5. And then you just work on the u2 minus 1, which is 1 over u, right? Which is just 1 over u here. You just rewrite. So here, minus 1 over 5, the constant outside, and this part is just u2 minus 1 is 1 over u, so 1 over minus 2, minus 1 over u minus 7, right? So this is like minus 1 over 5 outside, that will be 1 over 7 minus 1 half, which is, this one gives minus 5 over 14, right? Minus 5 over 14, so the final answer will be 1 over 14. That is the final answer. It's not really easy, okay? It's not really easy to get the final answer 1 over 14. Here, minus and minus will be canceled, okay? So we should be careful. We should be careful about the part when we change the variable into u, the lower and upper limit becomes minus GB, GA, and especially here, the GA is greater than the GB, so we should apply this simple rule to switch the lower and upper limit by this way. So we introduce the extra minus. Extra minus with this minus cancel out, becomes positive, right? Becomes plus. Then finally we get the answer is 1 over 14. So this definite integral will be 1 over 14. So that means the net area. The net area is a positive number. So the net, the region above the x-axis will be a little greater, okay? Will be a little greater than that. So any questions about this example? I think I'm almost done to give the example for definite integral and the indefinite integral when we apply the substitution rule. Any questions so far? Now let's check two important results, okay? The integrals of the symmetric functions. Suppose f is a function defined on minus a to a. If f is even, what does even mean? F minus x equals fx for every x defined on the domain. Then the definite integral from minus a to a will be double, okay, will be double from 0 to a. If the function is odd, what does the odd function mean? So f minus x equals minus fx. Then the definite integral from minus a to a will be 0 without any calculations. Now let's give some example about the even function. An example for the even function? We started before some very simple functions. X squared, right? X squared. X squared. Or cosine x is also even function, right? Is also even function. So to evaluate minus 5 to 5 for x squared dx, that will be double of the integral from 0 to 5. Okay, here be careful, should be minus a to a. That is even function, and it's the same for the cosine. From minus pi to pi, cosine from minus pi to pi cosine x dx. So that will be twice from 0 to pi cosine x dx, like that. Okay, like that. Then what is the example for the odd function? Odd function fx equals x cubed or sine function, right? Or sine function. It's an even function. Then from minus 5 to 5 x cubed dx, what is the answer for the odd function? Without any calculation, it's 0. And minus pi to pi for sine x, it's 0. Let me illustrate for the sine. Okay, for the sine, x y coordinate and y equals sine x. Let's draw the sine x from minus pi to pi. So this is minus pi to pi. Of course, those two parts should be symmetric, right? Those two parts should be symmetric to each other. And this part, the area is minus sine. This part is, this part is plus sine. This part is plus sine. This part is minus sine. So the net area should be 0. Okay, should be 0. So that will be all for the substitution rule. Now let's try one quiz. Let me send the question with 5 minutes. Okay.